simplest sort of radical equation to solve is a radical equation that says the nth root of some expression is equal to some other expression. We describe an equation that looks like this as having one isolated radical. Isolated meaning there's nothing else on that side of the equation. Now, to solve an equation like this, our first move is to get rid of that radical. And there are two ways we can think about this move. On the one hand, we could think of this as the same move we used in inverting a radical function. We can think, if I say that one expression is the nth root of another, that means the same as saying that the second expression to the nth power is equal to the first expression. Or another perspective on this is to say we can take the nth power on both sides, and then the nth power and the nth root cancel. We're going to prefer this second perspective because it's a little bit more straightforward and a little bit more in line with our usual equation solving, do the same thing to both sides of the equation steps. Let's see an example of using this process. Let's say we have the radical equation, the square root of 5x equals 2x minus 5. Remember, if we don't see an index on the radical, it's the square root. So to get rid of this square root, we're going to need to square both sides of this equation. And remember that 2x minus 5 squared means 2x minus 5 times 2x minus 5. Now the square and the square root cancel. Over here we're left with 5x. Over here we multiply. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is again negative 10x. Negative 5 times negative 5 is 25. I see that I have now a quadratic equation on my hands. This is probably something that's going to happen occasionally. That's okay, I know how to solve this. I'll collect like terms over here, and then I'll subtract 5x on both sides. Now I'll stare at this intently for about 7 seconds and see if I can see how to factor it. And not immediately seeing a way to factor, I'm going to use the quadratic formula. So x is, b is negative 25, so negative b, negative 25, plus or minus the square root, b squared minus 4ac all over 2a. What does that give me? Positive 25 plus or minus the square root, working out this stuff inside the radical on the calculator, 225 all over 8. Appealing to the calculator again, the square root of 225 is 15. So I'll get 40 over 8 or 10 over 8. That is x equals 5 or x equals 5/4. Let's make sure that actually worked. Plugging in x equals 5, I get the square root of 25 equals 5. That's good. However, plugging in x equals 5/4, I get the square root of 25/4 equals negative, 5/2. What's happened here? Notice if I square both sides of this equation, I get something true. But the square root is always the positive square root. 5/4 is an extraneous solution. We can introduce extraneous solutions when we take powers of both sides. How is this? If we take an even power of both sides of an equation, we can introduce extraneous solutions. Why is this? Well, in general, a number is not equal to its opposite. But if n is an even number, the nth power of x is the same as the nth power of its opposite. So if we solve by taking an even power of both sides, we should go back and plug our solutions into our original equation and make sure that it works. Let me have you try one of these. Solve the equation square root 3x minus 5 equals 7. Pause the video and try this now. All right, again, if there's no index, it means the square root. So this means we want to take the second power of both sides. The square and the square root cancel, and we get 3x minus 5 on the left. On the right, we get 7 squared is 49. And now we can finish solving normally. Add 5 to both sides. Divide both sides by 3, and we'll get x is 18. Now we're not finished. We need to go back and check that that's not extraneous. But plugging that in, the square root of 3 times 18 minus 5 is 7. Working out this part inside the radical, we get square root of 49 is 7, which is true. So x equals 18 is a true solution to this equation.